of our chapter number 2, acid, base and salt. In first section, in our first video, we have discussed about what is acid, what is base, and also we have discussed about chemical properties of acid. In the previous video, we have discussed about what is chemical properties of bases. Also, we have taken a detailed concept of neutralization. Also, we got the information about what is called dilution. By adding water into acid and base, which type of changes occur, that also we have understood. With that, we have also seen an experiment in which acid reacts with metal to give salt and dihydrogen gas. In today's session, we will move further to identify whether the given solution is acidic or basic. How we can know that the solution which we have, that is acidic or basic? Yes, you are right. With the help of litmus paper, we can know whether it is acidic or basic. But it will not be more accurate, right? So what we have to do? For that, we are using different types of indicators. So in today's session, we are going to understand what is called indicators. What is called indicators? Actually, indicators is a substance. When it comes in contact with acid or base, it changes its smell and it changes its color. So when it comes in contact with acid or base, it changes color and smell. Right? So to test our given solution whether it is acidic or basic, we have to use different type of indicators. Now, if we have a detailed study of indicators, we will know that there will be different type of indicators. Here, I am trying to list some of them. One is natural indicator. The another one, that is synthetic indicator. The third one is olfactory indicator, and the fourth one is universal indicator. In this session, we are going to study all these four types of indicators in detail. What is called natural indicator, what is called synthetic indicator, what is called olfactory indicator, or what is called universal indicator. So let's have a journey towards different types of indicators. So let's start with our first type, that is natural indicators. See, from the word we can know that this type of indicators, which is natural indicators, it is obtained from nature, right, in terms of plants. Generally, these natural indicators, they are litmus solutions and they are purple colored dye extract, which is obtained from lichen, which we know, right? The group of Halophyta, in that we will have the lichen, and from that lichen we can get a purple extract, which is our litmus solution, which behaves as natural indicators. You can see some natural indicators with their characteristics color. Here I am just discussing about some of the indicators. Here you can see that litmus, when it is added to the acidic medium, it gives us red color, and when it is in alkaline medium or basic medium, it will give us blue color. If we talk about red cabbage juice, which is obtained from its leaf, in acidic medium it will give red color, and in alkaline medium it will give us green color. If we talk about turmeric juice or haldi, In acidic medium it will give us yellow color, and in basic medium, alkaline medium, it will give us reddish brown color. If we talk about flowers of hydrangea plant, in acidic medium it will give us blue color, and in alkaline medium it will give us pink color. Our second type of indicator, that is synthetic indicators. These synthetic indicators are synthesized in laboratory or in industries. It is prepared in laboratories or it is prepared in industries. And some of the example of this type of synthetic indicators, it is phenolphthalein, methyl orange, then methyl red, and methylene blue. So generally these are the synthetic indicators which we can also see in our laboratories. Same, the functions of actual indicators, synthetic indicators, it will be same to indicate whether the solution is acidic or basic. Here you can see that some synthetic indicators with their characteristics color. In that we have taken generally two indicators. One is phenolphthalein. When it is added into acidic solution, it will be colorless. When it is added into basic solution, it will give us pink color, and when it is in contact with a neutral solution, it will be colorless. If we talk about methyl orange, so when it is in contact with the acidic solution, it will be red in color. When it is in basic solution, it will give us yellow color, and when it is in neutral solution, it will be orange in color. Now, the third type of indicator, that is olfactory indicators. Now, what happens in this olfactory indicators? Actually, this type of indicators, when it comes in contact with acid or base, it will change its smell. And some of the example of it is vanilla extract and onion. But the thing to note down here is that this vanilla extract and onion, they will only change their smell if they are in contact with acid. When they are in contact with base, they are not going to show a change in its smell, right? So vanilla extracts and onion, it will change smell in presence of acidic medium. It will not change smell in presence of basic or alkaline medium, right? So this way, these are the main points of olfactory indicators. Now, our fourth and important indicator, that is universal indicator. Now, actually this universal indicator, it is mixture of different indicators, and this mixture of different indicator, which we know as universal indicator, it is used to find out how strong our acid is, right? So to find out the strength, to find out the ionization of acid and base, this universal indicator is used. So how it will find out? So with the different solution having different concentration of H plus, means which have different concentrations, so according to that concentration it will give us different color, right? So according to acidic concentration, it gives different colors, right? So according to acidic concentration, and we know that acidic concentration is due to concentration of H plus. So according to the different concentration of H plus ion or H3O plus hydronium ion, right, it will give us different colors when it is mixed with the different type of solutions, right? For different colors, what we observe, we can identify that the given solution is how much acidic. Okay, so this way we have completed our 4 indicators. First we have seen natural indicators, then synthetic indicators, after that olfactory indicators, and now we have discussed about our universal indicators. We have understood the concept of how acid reacts with metal carbonate or metal bicarbonate, metal hydrogen carbonate. So let's perform an activity which will give us a concept of how acids it reacts with metal carbonate and metals bicarbonate. So let's see the activity. As in the earlier video, in the previous video, we have seen the activity, right? Similarly, this is the activity which is based on our concept of video number 1. In that we have discussed about chemical properties of acid, in which acid was reacting with metal carbonate and metal bicarbonate. So let's see and study an activity in which how acid is react with metal carbonate and metal is that experiment. What we have done, on one stand, right, we have placed a test tube. Right, how that test tube is arranged, you can see that here with the help of the test tube, Thiessen funnel, and with the help of delivery tube, we have done this type of arrangement. Now here you can see that we have taken metals carbonate, I mean that we have taken sodium metals carbonate, we have taken sodium metals carbonate, right, that will be our Na2CO3. With the help of this Thiessen funnel, we are adding HCl, hydrochloric acid, dilute HCl into it. So this sodium carbonate, it will react with the acid which is coming from the Thiessen funnel, and it will release the gas. Actually we know that this gas is carbon dioxide gas, but for tasting of that carbon dioxide gas, with the help of delivery tube, we are passing it from a calcium hydroxide solution. Now let's see what happens. The concept already which we have studied, that when acid it reacts with metal carbonate or metal bicarbonate, it gives us salt, carbon dioxide and water. If we want to write the reaction between this sodium carbonate and dilute HCl, how we can write? So as I said, I am taking HCl, aqueous solution of HCl, plus as a metal carbonate I am taking Na2CO3. It will react with each other to give us salt NaCl, which will be aqueous, plus carbon dioxide in form of gas, plus H2O, which will be in form of liquid. To balance the chemical reaction, here we can write down 2, chlorine 2, so here it will be also 2. So acid, it reacts with metal carbonate to give salt, carbon dioxide gas and water. If we take metals bicarbonate or metals hydrogen carbonate, so let's see, HCl, aqueous, plus NaHCO3, aqueous, that is our sodium bicarbonate. It gives us NaCl plus carbon dioxide in form of gas plus H2O instead of liquid. So this way, acid reacts with metals bicarbonate to give salt, carbon dioxide and water. So this concept we have understood in our first lecture also, but this is an experimental explanation that how it is done, how we can perform. Now one more thing, this testing of carbon dioxide we have already studied, that here calcium hydroxide solution, and if the gas is carbon dioxide, so what will happen? So we have studied somehow like this, that the calcium hydroxide's aqueous solution, from that if the carbon dioxide gas is passed, so we know that it will give us CaCO3, that's our calcium carbonate, plus water will be released. So this is our calcium hydroxide, this will be our calcium carbonate, and due to this carbon dioxide, the calcium hydroxide solution, it will become milky, so the color change will be also occur there. That we have understood. Now as we know that this calcium carbonate, it reacts with more excess of water and carbon dioxide, it will give us CaHCO3 twice. This is our calcium bicarbonate. We know that this calcium bicarbonate, it is soluble in water, right? So this way the metals carbonate is resulted into metals bicarbonate when it is reacted with water and carbon dioxide. So simple, our concept is clear here, that when acid reacts with metal carbonate or metal bicarbonate, or metal bicarbonate is also called metal hydrogen carbonate, it will give us salt, carbon dioxide and water. So in today's session we have understood about different type of indicators, what is called indicators and what are the types of indicators. Also we have seen that what is the definitions of different indicators and different examples. We have also seen that which type of color change is done in indicators when it comes in contact with acidic substances or basic or alkaline substances. In some cases we have also studied that what change in color is done when it is in contact with neutral substances. After that we have discussed this experiment, which is the question, it can be asked like this, that how acid reacts with metal carbonate and metal bicarbonate, explain it with suitable activity, right? So this type of question can be asked, right? We have to understand the question, we have to draw the figure and we have to explain whatever we are doing. In your textbook it's mentioned that 2 grams of sodium carbonate is taken, right? So they have given you the measurements, right? But the concept is same. If the measurements is changed, then also the concept will be same. So according to the question, we have to mention the answers. If it is said that to write the experiment or activity, so we will perform the experiment and activity, and after explaining it, we are going to write our equation. In your worksheet, everything is provided to you, right? In form of assignment, different questions will be given to you, right? It's our humble request, and already you all are doing well. We are receiving your homework in a large number with a qualitative work, right? So hope you will also complete your third worksheet and your third assignment. Thank you.